What up, what up, what up, ladies and gentlemen? It's Mr. Haddock here. What a great day to learn some science. Today's lesson is 2.9 air masses and weather fronts. Please make sure that you have out your online notebook and you are ready to take some notes on this topic. So I want to start off with a term that will end up most likely on your standard assessment, and it is convection. Convection would probably best fit with yesterday's lesson of high and low pressure systems. But with that being said, I want to talk about it today. So convection is a type of heat transfer, and it's the type of heat transfer caused when air circulates. Okay. It happens when warm air rises and cool air sinks. Convection is part of the reason why winds occur on Earth's surface. We feel the bottom parts of the convection. And then this happens all the time at your house when you boil a pot of water. So if we were to take a look at this first image up here on the right-hand side, you will notice that in the middle, the warm air or the warm water rises. This right here, the middle part where the warm air is rising, is a low pressure area. The warm air is rising. Now, where are the high pressure areas, or where the cool air or the cooler water is sinking? So that would be over here to the right and to the left of that low pressure area. And then what we would experience as wind would be right along the bottom here, along the surface, as the cool air is rushing back towards that low pressure area and away from the high pressure area. Remember, air flows from high pressure, away from high pressure, and to low pressure. And then you can also see an image of convection occurring during the day at the beach and at night. And we'll get into these types of winds a little bit later. But you can just take a look at those images and see that during the day there's cooler air coming from over the water towards the land, where the low pressure area is and the land is warmer. And then at night, it actually reverses roles. The land becomes cooler than the ocean water, and that's what causes the winds at the beach. So now let's talk about air masses. What specifically are air masses? We talked about air pressure systems, but let's talk about air masses. An air mass is a huge body of air that has roughly the same temperature, air pressure, and humidity. These can be thousands of square miles in size. They can be huge. They can take up part or a large portion of the United States. And then the air masses are classified by temperature and humidity. Remember, humidity is how much water vapor or moisture is in the air. And you can see that this weather map, these lines are called isobars. And they tell us the air pressure at various locations. So the higher the number, the higher the pressure. So you can see that there's a blue H there, and the pressure in that area is 124, I believe that's millimeter mercury. And then your low pressure area is right here at 922. That is quite low, and that's a low pressure area on that weather map. So remember, those lines are called isobars. So now let's move on to the specific air masses. There's 4 different types of air masses: continental tropical, continental polar, maritime tropical, and maritime polar. So they're relatively easy to remember. It's just vocabulary, and I'll give you an easy way to remember it. So the first is continental tropical, and this forms over land and near the equator. Well, you're like, Mr. Haddock, how can I remember that? Well, think of continent for over land, and tropical is located towards the equator. Tropical islands are near the equator. So continental tropical, land, equator. land warm. Now, what type of air do continental tropical air masses possess? Well, the air temperature is warmer, hot, but the moisture level, because there's not a lot of evaporation occurring over land, the moisture level is actually low in continental tropical air masses. Now let's take a look at continental polar air masses. Continental polar air masses form over land and near the poles. Their temperatures are cold, polar, cold, and because it forms over land, the moisture level is also low. Now, maritime tropical forms over the ocean. Okay, and tropical obviously means equator. Maritime, if they form over the ocean, that means that there's more evaporation that's able to occur. So yeah, it's going to be tropical and hot temperatures, but also it's going to have a high moisture content. There's going to be a lot of moisture in it because it formed over the ocean, and the ocean is where the majority of evaporation occurs on Earth. The last one is maritime polar. Maritime polar forms over the ocean, but near the poles of the Earth. So this is when the air mass is very cold air and has a high moisture content. These are your 4 air masses. They're nothing too complex or complicated. Just know the 4 words: continental versus maritime, polar versus tropical. Okay, and you'll be able to figure out the rest from there. There's nothing, you don't have to necessarily memorize everything. Just know what the words mean. Okay, so where on this map would each of these air masses form? Well, let's take a look. What type of air mass do you think would be located at number 1? Now, the white area is obviously the oceans, and the tannish area is obviously North America. So 1 forms over the ocean. So if you think about it, maritime or continental, if you said maritime, you're correct. And is that closer or farther away from the equator? What was it closer to, the poles or the equator? If you said the poles, then you would be correct. So this air mass for number 1 is a maritime polar air mass. Now, number 2, let's take a look. So there's 2 different answers here, but I will focus on just one of them. Number 2, they're both forming over land. If I'm not mistaken, I think number 2 is still forming over land. But anyway, let's focus on the light blue one, where it's forming over land and it's towards the pole. That would be continental polar. Now, continental Arctic is when it forms directly over the North or the South Pole. Okay, so those are even more cold. They're more frigid than the polar. The only one that you'll need to know polar for the assessment, just a heads up there. Now let's take a look at number 3. It's forming over land and it's closer to the equator. That would be a continental tropical air mass. And finally, number 4, forming over the ocean and near the equator, that would be a maritime tropical air mass. Now, what happens when these 2 different types of air masses meet? And when 2 different air masses meet, it is called a front. Okay, and we'll explain a little bit more in detail what the different fronts mean. So I got to give a shout out to my Ohio State fans out there. That's a picture of Ohio State versus Michigan a couple years ago. Of course, Ohio State won because they're just awesome. But anyway, back to fronts. Boundary formed when unlike air masses meet. Okay, and we'll talk about how they get their names. A cold front, we'll start off with, is formed when cold air quickly pushes up a warm air mass. Okay, cold fronts are associated with tall cumulonimbus clouds a lot of times. And the weather that is associated with a cold front are brief storms, heavy precipitation, followed by clear weather and cooler temperatures. Now, on a weather map, cold fronts are shown with the blue triangles, and the direction that they go is the direction that the triangles are facing, so that this cold front would be going downwards. So that's how those work. A warm front is formed when a warm air mass slowly pushes into a cold air mass. Now, the warm air mass will obviously go up over the cold air mass because, remember, warm air is less dense than cold air. A warm front will form flat clouds like stratus clouds. And the weather that is brought along with a warm front tends to be periods of long, steady precipitation, followed by warm temperatures afterwards. And you can see here that a warm front is represented on a weather map by red semicircles. And again, they travel in the direction that they are facing, and that would be upwards and slightly to the left. This picture to the right does a wonderful job of demonstrating the warm front. The next one is stationary front. So a stationary front, the key word stationary. This is formed when a weak cold air mass and a weak warm air mass meet, but neither one really moves. They kind of just stay still. They don't move, so that's why it's called a stationary front. They stay stationary. The weather of stationary fronts include long periods of cloudy days, possibly, before changing into a warm or a cold front. Eventually, one of these two air masses will take over and start to move. It's just when. Stationary fronts are represented on weather maps by a red semicircle and blue triangle line going in opposite directions. They don't move, so there is no direction. And the blue triangles and the red semicircles they point in opposite directions. Finally is the occluded front. The occluded front is when a warm air mass is caught between two colder air masses. The weather that is brought by an occluded front tends to be cool weather with rainy or snowy days, depending on the temperature, depending on how cool that air is. Occluded air mass or occluded fronts are shown by a purplish pink line, and they are going in the direction that the triangles and semicircles are pointed. And so it just depends. It's just one warm air mass is trapped between two cooler air masses and is lifted off the ground completely. So that is it for this video. I hope that you enjoyed it. Hopefully you took some great notes so that you can study them for the next standard assessment, which will be in a couple of days. Have a great rest of your day. Thank you for watching.